Welcome everyone for another observable lightning talks. Sorry, it's the December edition, and it's almost Christmas, to be honest. So for Christmas, wanted to have three great lineup with three great speaker, and I'm very excited because I was able to get those three speakers today. So it's almost a gift before Christmas. So if you saw the communication on the social networks, you'll see that there are three big names of the industry. So I'm very excited about it. And I will present them shortly to you once I present the agenda. So if you know, first of all, if you are connected, welcome. I am connected from south of France, close to Marseille. So let us know where you're connected from. Just tell us if you're coming from Europe, from US, wherever you are, you're more than welcome. We're going to spend an hour, a couple of minutes during this live stream. So if you never heard about the Observable lightning talks, the format is very simple. We start with three lightning talks. So three lightning talks means three presentation of 15 minutes. So to respect the agenda, if you have any questions, you can drop them. We will answer at the end, because at the end we have a panel discussion, and this is where I also going to take some notes and ask my questions directly to each of those presenters. So it's more like a Q&A/panel discussion. So if you want to interact with us, don't forget to drop your question into your chat. So if you're connected from YouTube or Facebook or Twitch or whatever you are from, use the feature from your main streaming platform to drop your questions, and we will answer them at the end at the panel discussion. So for today's lightning talks, observable lightning talks, like I said, I have a very exciting lineup, starting with I have Victor Fadget. You probably have heard of him. He's very active on YouTube, providing a lot of great videos, to be honest. So he will talk about from Kubernetes out of Kubernetes observability. So observability is a core component of the channel. So I'm very excited to hear more about that topic. So Victor has currently a small technical challenge with the internet. So he will probably present at the end of this session. But we will start tonight with David Flanagan from Rowcode. Very excited to have him. He will talk about leverage OpenTelemetry to enhance observability for command line applications. So if you're planning to instrument command line application, this topic will be very, very interesting. And as a second speaker today, we have Liz Rice. I mean, if you've heard about eBPF, you probably have heard about Liz Rice, very active in the community. So I'm very excited to have Liz here. She will talk about observing your Kubernetes network with Cilium. All right, so if you are ready, I think we can start with the first talk of today, which is going to be presented by David. Hi, David. How are you?
Yeah, very well. Thank you. How are you?
I'm very good. First of all, thank you to when I pinged you on LinkedIn. I was very excited when you say, yeah, sure. In December, I'm available. So I'm very glad that you're making it for this lightning talks. So the topic about command line application is obviously a topic that everyone is interested in. So I guess I'm not going to reveal too much because we have the abstract available, but I saw some Rust code behind the scenes, so it brings my interest, to be honest. So if you never heard about David, you have your own YouTube channel, the Rowcode. So could you tell us a bit more about Rowcode?
Yeah. First, I'll just say thank you for inviting me, and thank you for your channel, because it's full of wonderful content on observability, and I love it when you publish new videos. So thank you very much for all your hard work. The Rowcode Academy has been what I've been working on for the last number of years now, trying to make cloud native and Kubernetes less of a challenge, which is a difficult job. But, this is an evolving, changing landscape, moving with incredible velocity. And I just want to do my bit to try and make that easier for people that are adopting Kubernetes, microservices, service mesh, and everything else that comes along with that. So my channel just wants to help.
And I know a lot of people that are struggling with Kubernetes, so check out David's content. It's very well structured and well presented. All right, so I think I will leave you on stage for the next 15 minutes. So good luck, and see you in 15 minutes.
All right. I mean, I only showed up for the Cilium talk, but I guess I can talk about something for 15 minutes. Well, cool. My screen's there. Yeah, so we're going to take a look at OpenTelemetry in a slightly different light than you may be familiar with, because most of the content out there focuses on a different type of application, whereas I want to focus on the command line. Let's see if my thing will work. Awesome. Now, I won't spend too much time on who I am, because that's been handled pretty well, but I am Scottish. I founded the Rock Code Academy like 2-3 years ago now, and it's now my full-time job, which I'm very fortunate and privileged, and I'm very happy to be doing. And the technologies that excite me are the technologies that I make content on. So cloud native Kubernetes and server-side WebAssembly are fantastic tools, and I hope you enjoy that stuff as well, even though we're not talking about that today, but that's another thing altogether. So why are we here? I have to remember to go the right direction. There we go. I have an open source project called Comtria. If you get that reference to Stargate SG1, well done you. But it is a Rust application that performs some degree of configuration management, at least enough for you to provision your own machine. Little known fact about me, but I wipe the operating system on all of my machines every 30 days. Because I like a fresh machine, I enjoy setting up again and getting rid of all the rubbish. But in order to be able to do that, you really need to have strong automation for reconfiguring that machine. And Comtria was my approach at learning how to write a Rust project, because Rust is an exciting language and I wanted to get familiar with it. And it led me down this path of, learning a new paradigm, a new programming language, the way that they work, but not just that, but then all of the third-party libraries. And sometimes you just need a little bit of help. So I reached out to a friend of mine and just like, hey, what should I be using for like log output? Like, and all the other languages I've worked with, there have been really good libraries that handle the ability to build TUIs or print text with different colors and boldness and make it all look nice and shiny. But in Rust, I just had no idea. So my friend Anna said, use the tracing crate. And I was like, what? Why would I need a tracing crate for log output? And I went back and I was like, I just want to print some text to the buffer. I'm not a machine. I'm not writing structured logging. I just want to say, yeah, this thing's installed. And Anna just said yes. And I was like, wonderful, not confused in the slightest whatsoever. So here I am adding this tracing crate to a library, no idea what the hell I'm doing. And I just want to print some text to the user to let them know the job is done. And if we fast forward now, this is not the best that I ever got. And that's just because Anna has helped me out so much over the last few years of learning Rust. But it's probably the most important piece of advice that I've ever had, because it is now using the tracing crate is now a core component of every single Rust application that I write, whether that be a web server, gRPC, a local command line, anything, even WebAssembly. And it's just opened up so many different avenues to the way that I build applications personally, that I want to share why this is so cool and why you should be taking a look at this crate too. And I hope that you're looking at Rust and looking at that as a possible, language or runtime for your next application. Now, it's really, really, really easy. And this comes down to a few things in Rust that we'll talk about in just a minute. But adopting the tracing crate to give you observability into a command line application, along with a whole bunch of other benefits that this crate brings, is super easy. And in preparation, for this session, I decided to Google it, because I was like, surely someone has talked about this before. And unfortunately, I just couldn't find anybody using observability for a command line application. Now, potentially, I'm not very good at Google. That could be true. But every example that I found was just talking about a distributed system. It was talking about microservices. It was about network communication from A to B. So I then did what everybody does in 2023, and I asked the machines. I fired up a session on ChatGPT, and this was the response. Essentially telling me that, yeah, I mean, you could use OpenTelemetry this way, but, most people don't, and they use it for all the use cases that we've already kind of touched on and covered. So I thought, fantastic. This is definitely something we need to talk about. What's the plan for today? Well, let's start with the things that I'm not going to discuss. And that is, what is OpenTelemetry? I'm going to assume that you have some understanding. You've used OpenTelemetry in other languages or frameworks, or for your distributed microservices and systems. I'm not going to tell you when you should use OpenTelemetry, because I personally feel that the answer is always, and that's a relatively short conversation. Where should you use OpenTelemetry? Well, that's not really a question, but I just wanted to follow the format of what, when, where. And then why should you use OpenTelemetry? And again, we want visibility into our applications. We need to get metrics or understand how our application performs, regardless of the platform or where it runs, on your users' machines, in your data center, or in a browser. The things we are going to discuss, no surprises, Rust. We are going to have to take a look at some Rust code in order to see just how amazing this tracing crate is. We're going to be talking about command line applications. I'm not going to spend too much time on how to build like a Rust application that is a command line. We will look at one crate called struct_op, and it's just a fleeting passing because it's really cool and it makes these things pretty much trivial. And all of the automatic instrumentation that we're going to see today happens because Rust has really great support for procedural macros. These are compile time, essentially code injection, that gives us a whole bunch of new features, code, blah. I don't know what word I'm looking for. It enhances our application, and we don't have to write the code ourselves. If you're familiar with aspect-oriented programming, there's kind of some crossover here. Now, I'm not going to show you any of the Tokyo project or tracing code, except for the small bits of instrumentation that we do implement. However, if you want to learn more, you should definitely go check out the Tokyo RS GitHub and the Tokyo RS docs, because there is a wealth of amazing projects underneath that organization. And just because I feel like I have to say Rust 3 times, we're going to just continue to talk about how amazing Rust is and how fun it is to build these applications. Now, OpenTelemetry for command line applications, I just feel that we need to know more, but should we always be doing this is a really tricky question to answer, because maybe if we think about a standard command line application process, you're a developer, you write the code, you build it in a continuous integration system, push an artifact to GitHub releases, people download it. Are they going to be comfortable sending you any sort of distributed traces or OTel information? Like 100% not, right? It's just not going to happen. However, if you're running these applications in your own infrastructure, then of course you should be instrumenting them in a way that you can understand them. But just because the user, the end user, isn't going to be comfortable sending us OTel or OTLP information, doesn't mean that they don't want it available for when something maybe does go wrong. It's also really difficult to profile applications. This isn't easier. And by profile, I mean understanding the CPU and memory footprint, disk I/O, network, etc., to understand if we have problems in our code that can be further optimized or made more efficient. However, this is getting a lot easier these days because of eBPF and a really cool project called Parka. If you're not familiar with them, I'm not going to talk about them at all today, but you should go check out my channel where there is lots of content on this. Now, we definitely cannot profile an application that's running on an end user's machine. But if they do run into problems or they suspect there's an issue with the application, it doesn't mean they can't provide that information. If we remember back to the start where I was talking about Comtria and me using tracing for just basic output to the user, if that output is shown to them in a way that is consumable and looks normal, but under the hood just filled with metadata that they could get and they could post to a GitHub issue, that's a really useful feature. And if you need to print, something to your end users, why not fill it with the metadata to make everyone's lives a bit easier when something does eventually go wrong? So we're going to spend the rest of this session taking a look at Rust code, procedural macros, and the tracing crate as well as how to get this information into Jaeger using the OTLP collector. And I think I have about 5 minutes left. So let's show you the application first, if I can remember how to run it. So we have two different binaries here within my cargo project. Not important, but I will have to switch between them, so I'm just going to mention it. We have the ability to run the simple binary where we get some log output. Here we can see that it says this is an error. It is not written by any AI. Right? This is a log line that I added to the application to log an error. Now we can begin to add or change the verbosity level of this application with a V. And that's one. Let's see. Oh no, I'm going to have to. It's a cargo run. So if we add one, we should get the error, the warnings now. And this is just a debug trace joke. It is written by AI. I'm sorry. I did have ChatGPT write a joke just because I was running out of things to put into log levels. So as we show you more, yeah, I can only apologize. As we add 2 levels, we now get info. And if we add flake, thank you. And now when we add 4, we're starting to get the debug information. So that's where our joke is coming in, and we're going to add 1 more joke to get trace level. The joke is there. It is terrible, but you know, AI isn't good at everything. What we can see through this output is that we do have some sort of computational task that we may want more information on to understand the way that the executable runs through the stack, how the functions are called within our application. So while we always think of distributed tracing as a network hop, it can just be a function within your application, and understanding the performance of these functions gives you invaluable insight that mean you don't need to go down the profiling path if you don't have to. Something else that's quite cool about this is that we can change the format. So while we're presenting the user with something that's not great output, I haven't tweaked this at all, but we do have the ability to toggle it to JSON. So if we asked for JSON logs, we could get them. We could format them with JQ. We could process them. And if you really want, there's a pretty formatter that makes it look like something else. Whether that's pretty or not is up to your interpretation. So we do have the ability to get information from this application. If we run it one last time, we'll see that we have some sort of computational task, but we don't have any information yet that tells us why this is computational, or at least computationally heavy. So we can make a change to our code. So I'm going to open main.rs, and we'll take a quick look at the structure of this code. And if Henry can just type into the chat how long I have left, that would be great, because I've lost track. This is the struct.create here. We can see we've got our format flag, and we have our verbosity. This is how we get these flags and pass them in. We configure a few things, and then we set up a tracing subscriber. This will become important as I show the OTel stuff, just because there is ability to take all this information and push it to somewhere. We call 2 functions, levels and spans. So if we take a look at our simple RS, where these 2 functions are, these functions are instrumented with this procedural macro. This macro just says, enrich this function with a span, open a span and end a span when the function starts execution and finishes execution. We print out all of our information, and we have the same on our spans. Now, this is a very contrived situation. Let's up the computational from 3 to 10, and this time we're going to add some manual span information. We don't just want functional spans, we want to open up intermediate spans within the function to say that this is a loop that we're in. Which just means that we can run this again, and we'll get even more information. Hopefully. Oh, I've set that to 10, and it's going to take like... Let's keep it at 3 for now. All right, so nothing there yet, but let's go back and change our format JSON and type it through JQ. Oh, good. Where's my spans? I'll type it through JQ. Am I missing it? Save the file. Ah. All right, what have I done wrong? We'll come back to it in a moment. Now, this should have kept log levels to tell us, oh no, I just haven't added anything here. Let's do info and then add a thing and then run it one more time. Now we have our log line here. And we're just using the log line because we're not pushing this metadata, these metrics, these traces and spans anywhere yet. So the log line just forces it to come to the buffer. But inside of this, we can actually see the message for computational task 1, which was set when we opened the new span. And we've got the loop parameter here, which is the span metadata. Okay. Now, that's cool, that works, we can get information, but we want to push it and visualize it like we do with all of our distributed data or our traces. So this is the implementation in OTel. I do not have time to go through this, but I will share a link. So let's just spin up a demo. It runs a Jaeger container, sleeps for 5 seconds so it gets healthy. Not the best way to do it, but it'll work for now. Now we need to create a span. I'll do cargo run, and this time I'm going to use the OTel bin. And just because we can get this data in real time, I'm going to come back in and bump this up to the big number, and we'll let that run, and we'll pop over here. So now we have our CLI application where we can find all of the traces, and we can see each of the steps or spans for the functions as well as the loops that happened within our application. And we can see the warnings and the logs and anything else that we need. So now we have full visibility into our application, and I can keep refreshing this as those loops process and consume more and more time. As you can see, 2, 3, 4, 5, 6. This will go all the way up to 20. So a great way to give good output to your end users and capture enough information to make your CLI application observable. Thank you so much.
All right, thank you. Well, it was almost at the limits because I was looking at the timing, but
Yes.
I saw that you were struggling on the demo, so I said, let him finish. And I was very eager to see Jaeger, so that's why I was saying, come on, generate traces. But great. I have some questions, but like I said, I will leave it at the end. So thanks, David. And I suggest that we move on to the next speaker, which is going to be Liz. Hi, Liz.
Hi.
How are you?
I'm all right. Yeah, pretty good. Just fighting with those demo gods a little bit, but we'll see how it goes.
There's always a challenge when it comes to live demo, for sure. And I was looking while David was presenting. I was looking at your screen because I was seeing your screen. There was a lot of things were happening. And say, oh, no, she is finalizing everything. So great.
Yeah.
So if you've never heard about Liz Rice, first of all, Liz is very active in the eBPF community. So she's a chief open source officer at Itof Island, which is the main company behind Cilium, Humble, and a lot of. She's also part of the eBPF eBPF Con and all those organizations. So she was speaking at KC Austria. She did an amazing job, to be honest. So I'm very excited to have Liz here today. Presenting, and you are touching one of the topic that I covered a lot of months ago about Cilium and Humble. I really like those products, so I'm really eager to see if new things has been added into Cilium on that area. So I will let you for 50 minutes, and I will get back to you So good luck for your presentation, and I hope the demo goats are with you.
All right. Yeah, thank you. So I want to talk a little bit about some of the network and security observability that we have in Cilium and the observability component of Cilium, which is called Hubble. And all of this observability that I'm going to show and talk about is enabled by this technology called eBPF. So I thought I should really quickly just make sure everybody is on the same page about what eBPF is and why it really helps us with observability and security and networking. But we'll concentrate on observability today. So eBPF allows us to run custom programs inside the kernel. And if I get on the right window, so the kernel is the part of the operating system that interfaces with hardware. So whenever you're doing something like writing to a file or sending a network message or allocating memory, all of these things involve the kernel. Now, eBPF programs get loaded into the kernel and they're attached to events. And those events might be accessing a file or a network packet arriving at a certain point in the networking stack. There's innumerable types of event that we can attach our eBPF programs to. And then we can use those, have those events might be triggered by our applications. They might be triggered by network messages arriving. So depending on what kind of eBPF programs we write, we can use those to observe these different events. And our applications are running in user space. This is the other part of the operating system that isn't the kernel. And the thing that's really cool is there is only one kernel, however many applications we're running. There's a single kernel. And that's even true in a Kubernetes environment. When we're running those applications inside pods, those applications are in user space and they're all sharing the same kernel if they're running on the same virtual machine or the same Kubernetes node. And that means if we write our instrumentation code, our observability code in eBPF, we only have to instrument that kernel the one time or with one set of eBPF programs, and it can see what's happening across all of those pods. So whatever our applications are doing, whatever network messages they're sending and receiving, whatever file access, whatever interesting things they're doing, if we attach eBPF programs to those events in the kernel, we can observe them. The kernel is also involved in coordinating different processes. So it's aware when Kubernetes does things like creating containers. And we can use that to instrument the Kubernetes identities that are going to make things much easier to debug programs if we know things like what services are involved, what nodes things are running on, what namespace, what pod, and so on. The really cool thing about the fact that we can instrument the kernel is that it's completely transparent to the application and the pod configuration. We don't have to change anything about our pods for the events to get triggered in the kernel and for them to be visible through eBPF. And that means if somebody does try to do something malicious in our node, whether that's in a pod or on the host itself, that activity can be visible to eBPF. And that's really powerful for observing security events and really understanding what's happening across the whole system. David already mentioned some eBPF-based tools. The ones that I'm really going to concentrate on today are Cilium, which is best known as a networking solution for Kubernetes. It's a CNI plugin and more. There's a sub-project of Cilium called Tetragon, which focuses on security observability. And I've realized I've got the old logo here. I need to update with the new fabulous Tetragon logo. And Hubble, which is the network observability component of Cilium. So in what I'm going to try and show in the demo, we're going to go to a galaxy far, far away, where we're going to see there are some pods running, and we're going to be able to observe the traffic. We're going to be able to observe individual network packets as they flow between the craft in this galaxy. The really important thing here is that we have access to the Kubernetes identities. If we want to debug network problems in a Kubernetes environment, we need to know what are the pods involved. We can't just use IP addresses and port numbers like we did in traditional environments, because those IP addresses get reused dynamically. Pods come and go all the time in Kubernetes. And so the IP addresses that they use can get reallocated dynamically. So it's no good knowing that traffic went to a certain IP address today when yesterday that IP address was potentially allocated to a completely different pod, perhaps in a completely different service, perhaps in a completely different namespace. So we have the pod identity information. We're also able with Hubble to get the application layer, the layer 7 information about network traffic. So in this little example that I'm showing here, we're seeing it's a DNS request, and we're able to see what the address is that's being looked up by DNS, what answer is coming back. And what we're seeing here is Craft querying the Star Wars API and getting back the IP address of that. And of course, if we are a security team in the Death Star, or perhaps we're the network team, we're the platform team, and we would like to be able to picture what's going on in in the galaxy. And one of the things we can do that with is the Hubble UI. So I'm going to see now, as I mentioned, the demo gods have not been super kind to me yet so far today. So I'm going to see what's running and see whether we can show some of this live. Okay. So just to prove that we have some pods. Yeah, we have some pods running. We have a couple of Death Star instances and a TIE fighter. And in the top window here, we can see that Hubble UI output. This is looking at everything that's happening in that Endor. It's actually a namespace in my example here. So we can see, if I just sort of scroll back for a bit, we can see things like DNS requests going to core DNS. We can see here's some DNS requests for the Star Wars API, and we'll probably find the response. Here we go. Here's the DNS answer coming back to the TIE Fighter pod here. Okay. And we're getting all of this traffic. We can filter this if we so choose. We can filter by things like what port it is, what pod it is, what traffic type it is. We can filter out things like security policy verdicts. There are many, many things that we can filter this data on. But however much we can filter it, it would be nice to see it in a pictorial form, right? So that is where the Hubble UI comes in. And hooray, this is still running as well. So this is showing us a service map. It's really presenting the same information that we saw from Hubble, but in a more visual form. So we can see that the TIE Fighter here is communicating to the Death Star. It's also been communicating to the Star Wars API. It's been sending something to Disney.com. It's had to make some DNS requests as well. And there's also some traffic here, and I think this is from earlier on in the day, from a different namespace. The Millennium Falcon has been around and trying to communicate with the Death Star by the looks of it. But again, we've got all this information about individual network packets, and we can also get more detail. So we can see, for example, I've clicked here on an egress packet from a TIE Fighter pod, and it's going to DNS. So I found a DNS query here that's traveling on port 53 and is a UDP packet. So this kind of data can be really useful if we want to debug network problems. Okay. The next thing that I wanted to show you, and this is where if you're eagle-eyed, you will see why that something has gone wrong here. So what I'm trying to show here is that Hubble not only generates these individual flows for each network packet, but it also generates Prometheus metrics, which we can then pull into a Grafana dashboard like this one. And so an hour or so ago, this was working, but something has happened that's making it actually maybe it's yeah, I'm not very convinced about this because and I think if I refresh this, we'll see what happens. But yeah, something has gone wrong here, because we were seeing things like the request duration, so like the P99 and P50 for request durations. We were seeing things like the incoming request volume, but right now that seems to have dropped to almost nothing. But you can nevertheless, even though it's not working now, you can see how it was working earlier in the day before I messed something up, and how useful this would be to understand how your network is behaving, understand where traffic's coming from, understand whether traffic is failing, whether traffic is subject to particular latency issues, that kind of thing. We've also got some things like the CPU usage, so we can tie spikes in CPU usage to high latency, for example. Now, maybe we want to be able to drill into individual requests here, and I'm going to just try to skip ahead a little bit in my slides and find, here we go. So this is a screenshot of that same dashboard, but with some different sample applications running. And what this also is showing is things like these exemplar points where we can integrate with Grafana and Tempo to get these individual examples of flows. And if we find a particular, this is an example with the exemplars showing on the graph, and we can actually look at OpenTelemetry traces as well through the Grafana dashboard because of this integration with Tempo. And so we can see here, clicking on an exemplar, hard word to say today, and in this example, we can see something that actually a request that had to be retried for a second time as it went from the resume service to the core API. Or rather, that resumes request was made twice. So that's kind of intended to illustrate the kind of detail that you can drill down with Hubble. All of this is essentially based on Hubble collecting those flows, collecting trace if your application is enabled with OpenTelemetry, and generating those Prometheus metrics that Grafana can then present in this very nice way. There are also, I mentioned Tetragon earlier, and that can be used to detect things like sensitive file access. And again, we can create Grafana dashboards that can show us things like which files have been opened. Are there particular files that we really don't want to see opened? Like, we might be perfectly happy for something to be running the cat executable or the vi executable, but we don't want them to be running cat or vi on the etc. shadow file that contains passwords. So this is the kind of security information that we can generate again and show in Grafana through Tetragon. So that's been a pretty quick run through some of the observability capabilities in the Cilium project. I hope if you take something away from this, it's the fact that eBPF allows us to gather this really detailed information that can then be kind of annotated by tools like Cilium and Hubble and Tetragon to provide this Kubernetes aware information. And then we can take those sort of detailed individual event traces like a network flow, and we can turn those into visualizations that are much easier for humans to make sense of. And that allows us to do things like debug network policy, or notice when sensitive files are being accessed, or even to spot when data is being exfiltrated. We can use it to see when unexpected executables are being run. We can use it to identify privilege escalations. All of these are possible using Tetragon. So we can use these visualizations not just to observe and debug network problems, but also to solve security problems. And with that, let me just bring up a quick, there are a couple of books you can download from the iSurveillance website to give you more details about eBPF, should you want to dig into eBPF and particularly security observability using eBPF. Okay, I think I'm just about on time-ish.
You are perfect. It's really tight. Wow, amazing.
Awesome.
I have, and in fact, I saw that the Grafana dashboard were there was some problem with the data, but most of it was fine. So at least the god of the demo was quite kind of gentle, I guess, with you.
It was working fine like a couple of hours ago. So I've disabled something, and yeah, it's all me.
So I have some questions, but you suggest that we jump to the panel discussion because unfortunately, Victor has an internet issue on his side, so he won't be able to present and demo, but he is available for the panel discussion. So let's jump into the panel discussion. So I will take advantage of asking all my questions, and of course, if you have any questions, just ask them as well. All right. So first of all, Victor, what a disaster we are in 2023 and you're fighting with your internet.
I think it's my router. I have Warby router mesh something. Anyways, things happen.
Yeah, it happens for you. It's sometimes it could be even worse than the god of the demo internet sometimes, to be honest. So I have a lot of questions already, and I will probably ask also Victor later on, maybe to just tease what you had in mind to present. So maybe we can share some assets later on to the audience. But starting with David. So David, you mentioned the command line application with tracing. And when I looked at the OpenTelemetry project, there were some few libraries that were mainly designed to be experimental, to do some tracing in shell, in bash. So you can import a library and generate traces. And I think there is also another Python script, Python tool, CLI, that allow you to grab some information and generate traces. And I was wondering if you have had the chance to come up to those projects before starting the instrumentation of your app. Oh, we don't hear you, David, for some reason.
That's my fault. I muted myself during the session. Yeah, I mean, I'm sure those libraries are really interesting. I'm not familiar with them. They're not written in Rust, so I just don't have to, I just focus so much on Rust these days.
And so
it's dead to David.
I know, like even when I open a Go project now, I'm like, oh, here we go again. I mean, and I love Go. It's a great language, and I've enjoyed working with it over the years. But there's something about Rust. The ergonomics of it are just so great. The error messages are great. The developer experience is great. And I don't want to just sit here and Rust fanboy for the next 10 minutes, but I could easily.
And so you did a wrapper in Rust that catch because I had a limited screen, so I didn't see the entire code, and I was wondering if it was a library, like a wrapper that the community can reuse if they do any REST-based command line applications.
Yeah, so that's the best thing about it, and I got a little bit rushed at the end because I was running out of time. But the tracing the library, right? It's something you can use in any Rust project, and you can print log lines, error, debug, warning, info, etc. But behind the scenes, it's collecting a whole bunch of metadata about the function of this end. It's opening spans. It's doing all of that stuff. So even if you don't want to use it, it's still a very valuable library. But the fact that you have used it means that you can literally type 2 lines of code, and all of that information can either be dumped to your terminal, pushed to Jaeger, or an OTLP collector. It's entirely up to you. So it just seems like a win-win scenario. Like, use the library, get the whole host of benefits, and then if you really want to, you switch on even the cooler stuff behind the scenes.
And then if like a section of the code is failing, you are catching those exceptions and generating span. You setting the span into an error, or you adding an event with the details of the error? Or what do you
Henrik. Rust doesn't crash. Come on. There are no exceptions because everything is caught and handled correctly. But yes, that information would be captured by a tracing library. You could then decide to push it somewhere, print it to the terminal, do whatever you want. The idea is just that this library is collecting all this information for you, and then it's just there to be used, which is
awesome.
Fantastic.
And the other last question I had was you were looking at the logs, and with the OpenTelemetry logs, now you can attach the trace context to your log lines. So then when you ingest those logs, or if you let OpenTelemetry collect it, then you can attach the log events, or the events coming from a log line to the actual trace. Do you also do that, enrich the logs with this trace and the span ID?
Well, it's all done automatically for you. So every time you call a new function, it creates a new span, and everything is collected. All the metadata that it has about the frame pointers are collected to that point, and more, because it's compile time aware. And you can also add any arbitrary data as well. So as you're opening spans, as you're logging stuff, you're enriching that metadata with user IDs if you need them, IP addresses, or remote hosts if you're trying to do some networking, whatever that may be. It's just 4 or 5 different functions that allow you to capture context and give output at the same time.
So maybe that will be relevant for everyone. So if you can drop the URL to the repo, I will share it later on. But I think it will be worth to share it to all the attendees. Victor, Liz, do you have any questions to David?
I'm tempted to ask something about, I don't know, Rust. It's been like a couple of years since I tried using it, but has it? You said like the ergonomics are really good. I remember things like error handling changing quite a bit, and maybe some other sort of fairly. Error handling changed quite a bit in Go as well, so it's not like Rust is alone. But I'm just wondering how does it feel like it's stable? Does it feel like it's a stable ecosystem these days?
Yeah, definitely. In the early days, whenever I needed to work with, Kafka or something like that, the libraries weren't quite there yet. But now I don't think I've ever went to crates.io and searched for something that's not been available. The error handling within the standard library is still very much just kind of, but there are some really good libraries that have just been kind of adopted as standard now. That people use for error exceptions handling and so forth. And with async await now being stable and Rust stable, the entire way that we handle and work with futures, promises, whatever you want to call them, everything about the language is just now, it reads like nice code. It always used to kind of be super performant and safe and robust. But sometimes reading the code was a little bit, that's scary. And there still are scary parts, right? Like there's still lifetimes if you have to start handling that, or if you want to use arcs for doing multi-threaded stuff. Yeah, there are the scary parts of the language. But for most applications, maybe you could avoid them. I'm not sure. But yeah, I'd say it's stable. It's much better.
I think it was the first language I ever came across where you can't just like look at it and guess what it might be doing, because there's meaning in those there brackets and things.
Yeah, that the procedural macro stuff in Rust, unless people have come from certain .NET languages, they're probably just not familiar with annotating functions and classes in that kind of way, especially coming from a language like Go or C, with none of that functionality exists. So it can have quite a high learning curve, and I think that's well documented, but definitely worth getting familiar with, in my personal opinion.
Victor, do you have any questions for David?
No, I tried Rust years ago. I got scared with it, and now I need to dive into it first before I ask anything. So I'm a Rust virgin.
Well, you do know that there are many parts of Kubernetes now that have got some Rust implementations and Rust rewrites coming along. So it might end up in your laps quicker sooner than later.
Yeah.
And you can write eBPF code in Rust now as well. So.
No way. I was not aware of that.
Yeah, the Rust eBPF now. Yeah.
Okay, because I was using the Python and the Go library, but I never heard about the Rust one. So okay, interesting.
Yeah, there's a library called Aya that
So that,
I think
does that mean, Liz, that you will rewrite Cilium to Rust?
in an
Is that what
afternoon.
you're hinting?
Yeah. I would say there's no current plans.
Yeah. Sorry,
Um,
we've taken over your show and made it the Rush show. Sorry about that, Henrik.
no worries, no worries. I had a question for Liz because I looked at Cilium and Humble, and I also was digging into the hit EAT a couple of months ago. I really like the fact that it was exposing Prometheus exporter, so you can utilize it. And at the end, you showed us in the demo the exemplar with the traces. So it's Humble that is. So if you don't set an OpenTelemetry collector, it means that Humble detects that there's a trace and collect it and send it, or is this just because it's going through a collector? So how did you
I'm a little bit out of my depth there. I think it is going through a
collector on that? Yeah.
Yes.
And I was wondering because I thought, because I was playing with different service mesh. And sometimes when you set some network policies, like I want to have a request timeout or traffic split or something that will affect the actual behavior of the network, turning on spans on the proxy side to be able to get those details on each proxy, say, I'm rate limiting you or whatever, was very relevant. And I was wondering if Humble, because I know Humble with the UI, if you put a Cilium network policies, you can see that the traffic has been blocked. You see everything live on the UI. And I told myself when you were showing, I said, it would be amazing if those details Humble was able to produce, add or a span event or a log event or something to the OpenTelemetry stack. So then we attach the Humble events that say that this has been dropped or this has been filtered. So that it will be like very useful from the observability standpoint. Have you already thought about that aspect? Is this already a feature or?
It's not a feature that, directly in the Hubble UI. At the moment, we're really leaning on Grafana for providing that kind of visualization. And you can, I didn't show it today, but you can actually even see the Hubble service map inside of Grafana. Whether we then also try and replicate that same experience in the other direction in the Hubble UI, maybe that's a good thing we should do. I'm slightly of the opinion that we don't need to sort of reinvent the wheel, and Grafana are doing such a great job of providing those visualizations and the ability to kind of cut up those metrics in whatever way you want to. So maybe we're better off concentrating on collecting those events and providing that kind of flexible, I want to say data source. I think data source might have a particular meaning in Grafana, but you know what I mean, a source of events.
Yeah, I mean, every observability solution is a storage or is a data source, like you said. So if you are exposing those in a common format, like OpenTelemetry, then everyone can consume it and do whatever visualization we want depending on the tool, of course. But I think that will be a great way of adding this feature. Same thing for Tetragon. I know that from other security agent, they are very generating a lot of events in the logs. So then if you parse those logs, you can also keep track on this. And I was wondering if Tetragon also has like this way of exposing information from a different way. That will be also an interesting point. What type of output you can do with Tetragon?
Yeah, so Tetragon generates its events essentially as a stream of JSON objects. The really important thing, and the thing that differentiates Tetragon from other security observability tools, is that it's filtering those events in the kernel. So let's say you only want to know about file access events from a certain set of pods, or you're only interested in a set of, maybe we only care about files that are in the etc. directory. There have been other tools that are based on eBPF that will collect essentially all file access events, send them all to user space, and then use a user space kind of filter to tell you whether or not it's met those particular conditions. What Tetragon's done and what the team have done that I think really moves the kind of state of the art forward is to do that filtering in the kernel. So it's massively, massively more efficient.
Okay. Great. Okay. Cool. Thanks. Victor, David, do you have any questions to Liz? This silence means no, I guess.
No questions. I mean, I've made it no secret that I think Cilium and Tetragon and Hubble combined are a superpower for Kubernetes. It's just nice to see it coming along, getting more adoption, and all the new features. Like I wasn't familiar with all the new Grafana tempo integrations. That's pretty sweet. So.
Yeah, it's nice, and there's new dashboards coming along, and yeah, I think there's quite a lot of interesting things that people will do with that. I really want to see people, I want to see a KubeCon presentation where somebody talks about using that dashboard, and here is the exact metric that they saw that pinpointed a real life problem. I'm really looking forward to that.
Yeah, so I will clearly dig into this and try to do the same thing, not with Grafana, but with obviously Dynatrace. But and that could also be useful for the Dynatrace users for sure.
Sure. Yeah. I mean, all of this stuff, most of it is based on Prometheus metrics. So if you can take Prometheus into whatever tool you're using to present these things, yeah.
And that's the good thing, right, about OpenTelemetry and all these standards now is that our data can be captured once in a common format and pushed whatever you want to push it. So.
Yeah.
That's the good point, is that you have an open format, so you can switch tool, you can select which visualization you want to use depending on the solution that you have. I think that's great.
Yeah.
So Victor, tell us about from Kubernetes out of Kubernetes observability. What did you had in mind? Because the title was so exciting, and the abstract as well. So what did you wanted to touch base?
So the idea is to so I work with Crossplane, right? That's my thing, and the idea is to, if we convert a Kubernetes cluster into kind of control plane, the entity that controls everything else, doesn't matter whether it's AWS or Azure or Google Cloud or other Kubernetes clusters, right? We have that constant communication where Crossplane basically is querying the APIs and bringing data back to that cluster. And that cluster becomes a sort of source of information, right? And if we connect that with observability, basically we get a solution from that cluster, from the data, from the metrics, logs, what's or not, in that single cluster, we can observe everything, meaning we can collect everything, whichever tool we're using, Dynatrace, Prometheus, what's or not, and essentially visualize alerts and what's or not that we are using for the whole system from one single place.
So if you you mean that if you use different, depending on the tools, you rely on the collector. So it means that you're able to, from a control plane perspective, manage the collector depending on on the usage of the applications. Do you also manage, say, the scaling approach as well, or is it mainly the making it available?
Making it available in the case of what I was hoping to present today, right? Simply everything becomes a Kubernetes event, and everything gets stored into controllers, and from there on exposed as metrics and collected by whomever needs it.
And the collector pipeline, is it an assets that will be I guess you store it into Git, and then from a GitOps approach, it will be upgrading the collectors, or how do you
collectors?
The OpenTelemetry collector.
Yeah, I mean that's exposed. I'm not saying necessarily that you will get all the data you would ever need, but that's all exposed as Kubernetes events and through logs and what's or not directly related really to GitOps, right? With GitOps, it's more like, hey, I can define in a Git repository something that gets synchronized with the control plane cluster, and that something becomes something, right? EC2 instance, RDS, what's or not. And once Crossplane establishes that communication, not only that it manages the state of that resource, but also it retrieves the information you might need for observing that same resource.
So because I was thinking with a cross-plane managing or managing the control plane, managing the data plane, and the OpenTelemetry collector will be one of the components of the data plane.
Yes.
And you know that the collector relies on the configuration file, which is the collector pipeline. And I was thinking, if you deploy it first and then you want to do some changes, Do you handle also the updates of the new pipeline in?
Oh yeah. Git, Argo CD, Flux,
Yeah,
cup
okay.
controller, whatever you prefer,
Okay.
gets to that cluster, right?
Okay, great. And so I guess you I mean, I know that usually you prepare demo, you already have always some repo, something that people can use or start or look at.
Yes.
Do you have any assets that we can share?
I do, but I cannot share now because I don't know how to do those things from my phone.
Oh yeah, yeah.
When I get back to my computer, I can send you the information. Yes.
Great. Okay. So all right. So Liz, do you have any questions about the Kubernetes Observability with utilizing a control plane, data plane that Victor just explained us?
I don't know questions so much, but I do think, multi-cluster is becoming such an important thing that, it's only a couple of years ago that people were like, yeah, no, that's not a real thing, but it is a real thing. Multi-cloud is a real thing, definitely.
But do you see
often for wrong reasons? I believe. I think that people go to multi-cloud just for the sake of, if tomorrow AWS goes down, then I will be able to recreate everything in Azure in 15 minutes. I'm not sure I believe in that, but multi-cloud is definitely there, right? Either because companies are acquiring other companies that use something else, or because you realize that, hey, this is good for this, but then if I need machine learning, I will go there. And also, my definition of cloud is not the same as being hyperscaler, right? The moment you use AWS and GitHub, you're using two cloud services.
Indeed. Yeah, it's true.
That's true.
And also people sometimes have to distribute for kind of compliance reasons. They've got certain data that needs to be held in a certain country, and that might kind of limit their choices in terms of which clouds they can use. So
of course,
there's
that's the whole premise of Crossplane is essentially, okay, so if you're managing stuff that is not necessarily only one thing, you need some kind of a place from which you manage those things, and that place not being your laptop.
And I think, being able to observe things across multiple clouds and multiple clusters is going to be, super important for people. Yeah.
Oh yeah.
Yeah, of course. Yeah, agree. But I was just wondering, in the multi-cluster approach, doing this service mesh with multi clusters. A lot of people was doing this multi mesh, whatever. Do you think that is still something that people are doing, or is it people prefer to do? I'm doing one network on one end and one other network on the other end, and I do some, let's say, some security tunnels between two kind of cluster, and I'm not doing a big mesh for that. Do you still see that people need this big beast of network?
So from a Cilium point of view, we absolutely do. And how you connect your clusters is that's a separate question. But having achieved internet connectivity between two clusters, with cluster mesh, you can do things like have shared services that, maybe you prefer to use a service on your local cluster if it's available, but if for whatever reason it's not available, you can use the same service from a remote cluster, and that is completely transparent to you as the developer, because Cilium's just going to take care of that for you. And that's also going to apply things like network policy across multiple clusters.
So it means that both DNS components from each cluster are sync. So they are discussing to figure out, this endpoint is dead. You will take over the request and so on.
Yeah, basically, yes. So they share a bunch of information about endpoints and service identities. Yeah, that gets synchronized between clusters, and absolutely, you end up being able to either randomly pick a backend pod across multiple clusters, or perhaps, as I say, prefer a local one, or even prefer a remote one. So,
Okay, cool. Do you have any, David or Liz, do you have any other last questions to ask to Victor?
I dare you.
When are we going to see the demo?
You can, as soon as my internet comes back. I'll do my best to record the video or something like that.
Awesome. All right, cool.
Nice.
Awesome. All right, so I think we are already at top in an hour and 5 minutes. So I think it's time to conclude. So we'll first of all, thanks everyone for taking the time to prepare those presentations. Even for Victor, you didn't have the chance to present it, but you take time at least to prepare it. Thanks, Victor. Thanks, Liz, and thanks, David. Really appreciate it, and I hope everyone enjoyed to have all of three of you available for this live stream. All right, let me conclude, and I will end up the stream. So thanks, and talk to you soon. So, so first of all, 3 lightning talks. Unfortunately, we have some live problems that always happened. But just to remind you, if you enjoyed today's live stream, don't forget to like and subscribe to the channel. And small promotion. Thursday, I would have a live stream on the Observable live coding session, where I have 2 maintainers of the OpenTelemetry collector that will take any questions related to the OpenTelemetry transformation language. So if you have any questions, if you don't know how to deal it, don't forget to connect Thursday at 6 p.m. European time, so Central European time, where we will have 2 maintainers available for 1 hour. So thank everyone for this to joining us for this live stream, and see you soon for another Observable Lightning Talks.